work. You see me do me dirt. Tell me about that work. When you walk a line, I'm in the cafe,
Precalculus 12, 9.2. You ready to rock? This is second podcast of our section. I hope you're ready to work. For our second podcast, or really 9.2 second section here. And a little Rihanna work, always helps things out a little bit. But oh man, I have too much fun. This is great. Hey, miss y'all a lot. Hope all is doing well with you. Hope spring break was great, and hope you're getting back in the swing of things. Again, all I can tell you is that this right here is getting us one step closer to being that last lesson of the unit. Really, last lesson for a lot of you as seniors. So let's do this. Let's keep pushing forward. Remember, the other day we talked about a couple things. We talked about a parabola. Now, a couple things with the parabola. We noticed that we have x squared, we have negative x squared, we have y squared, and we have negative y squared there. We also noticed that the foci always fell within the parabola, whereas the directrix on this top one would be equal distance from the vertex and foci to the vertex and the directrix. That would be a distance of p. Remember, we talked about that with our standard form. And some of you even were on the podcast the other night to be able to even identify with that. So again, that's what we're going to pick up on a little bit further. But now we talked about with conics that if I have two cones that are this direction, and you can kind of go to the previous one as well and check that out. But on this, if you were to cut this across sideways, we would have what was called an ellipse. Now, within ellipses and circles, one important thing to know is that a circle is something that has an equal distance around. Okay, we call that a radius. Whereas if you have an ellipse has a major axis, which is the longer version, whether it's vertical or horizontal, could be either. Still has a center, just like we did with a circle, but we have a major and then we have a minor axis. Now, within a circle, you'll notice there is no major or minor axis. It's just a radius there. Now, there's two other things we need to kind of mention. Just like with the parabola, we have what was called, we have two focuses. So if you have two focuses, we call them foci, or that's kind of a cool name, little gangsta name. Maybe I'll get a tattoo of that, foci there. But if I were to take a pencil and I were to connect a line to both of the foci within an ellipse, and I were to go around, what would happen was you would create an ellipse shape, okay, as you went around. So the big thing to understand is that it allows me to have distances that both of these would be a constant distance there. It allows us to make the shape of an ellipse. And important for a lot of things. Again, you kind of see some examples like in orbits or different things such as that. I think there's some examples even further out of where they're applied and utilized. So that's kind of what we're looking at within an ellipse. Now, within our equations, you'll notice that we have x and h, or x and y, both in the same spot. Usually x follows first, y follows second. If they're flip-flop, that's okay. But the big thing to understand is what number is greater on the bottom. For instance, a represents the number that is greater than b. So let's say that I had a, which would be, let's say a squared was 9, whereas b squared was 4. The major axis is the one that has the a, or the larger value, underneath. Okay, we call that the major axis. The lesser value is the minor axis, and so that should make sense to you. So if, let's say a, the larger value underneath, is underneath x, then we know that this is going to be a horizontal ellipse, whereas if the a is over or underneath the y, this is going to be a vertical ellipse. Okay, so just giving you an idea there. Now, let's say, for instance, on number 1, we were to graph number 1. Notice that the h and k still follows, instead of the vertex now, we have it at the center. So h and k is the center of our of that ellipse. Another important thing to note is if I had something like x minus h squared plus y minus k squared, and let's say nothing was underneath, or let's say it was, let's say this was a 9 and this was a 9, okay? Remember, in this, what happens is since these are the same, that means the major and minor axis will also be the same, therefore forming a circle that has the major and minor axis being the same thing. So now guess what? You'd have no foci, and you'd also make sure that you would mention that it would have a radius of a certain value. And we'll get to that in a second. So because this 4 and 9, 4 and 25, so on and so forth are different, we know the major and minor axis will be different as well. Look, in this example, we do not have an h and k. So we know at this point, our center would be at 0, 0. And our major axis, okay, would be underneath. So this 9 would be the major axis, okay? So that means this thing's going to be a vertical up and down, larger on the top than side to side. So in order to find what this major axis is, we take the square root of whatever this is. So this square root of 9 would be 3, okay? And what we're going to do is from the center, we're going to go up 3 and down 3, okay? So if I go up 3 and down 3, my major axis would be a total of 6. Now think about this. What would be the minor axis? Well, if I go square root of 4 would be 2. Again, since it's underneath x, that means we're going to go 2 to the left, 2 to the right for a total distance of 4 for my minor axis. Now, you might not have gotten all of that. And that's okay. Let's take a look at a problem maybe that will help us here a little bit. Let's take a look at this one. X squared and y squared. Now, in this example, since there's no transformation here, and I'll give you an example of a transformation like this one. This one would go left 2 and down 2. So this one would go left 2, down 2 for our center. But whereas this one would be at 0, 0 since there is no transformation. So we got 0, 0 there. Understand this, that since the 27 is greater than the 5, we know that the A, or the major axis, is going to be up and down. So in order to get how far it goes up, we're going to take the square root of 27. Okay, and usually I keep it as a square root, but right now, in order to kind of give you an idea of where this would be, let's do the square root of 27, which is 5.2. Okay, so what's going to happen is this is going to go up 5.2 and down 5.2. Okay, because again, it's underneath the y. So total distance is 10.4 from my major axis. Now for my minor axis, I'm going to do the square root of 5. So the square root of 5 will end up being 2.2, okay? So square root of 5 is 2.2. All right, for a total distance of my minor axis of 4.4. So I'm going to go 2.2 to the left, 2.2 to the right, and wherever it always comes from my center, not from the origin. So if my center changed, then obviously these points would change as well. So my ellipse would look something like this here. Now, if I ever ask for what are my vertices, okay, so the center 0, 0. My vertices are wherever my major axis is. So this would be 0, 5.2, and 0, negative 5.2, since it is my major axis there, okay? Now, a couple other things you need to just kind of know is where are my foci? Well, my foci is going to fall between my center and my major axis, okay, because there's going to be 2 of them. It will never be on my minor. It will always be on my major. So to kind of figure this out, what we have is kind of a formula that states that c squared equals a squared minus b squared, okay? Kind of see it on this side. C squared, where did I put that? I want to make sure I show it to you. Not there. Apologize, I'm going all around. C squared equals a squared minus b squared. You see it right there. So to find what my foci is the distance c from the center. So this c is like the distance. Well, let me just say this. Okay, so if I were to draw, let's say, this right here, the distance that I'm trying to find is c, which is right here. Now, again, because the foci is going to fall somewhere within the center to my vertice, okay, or to my major axis points. So to get this, what we can do is just take the 27 and subtract it by 5. 27 minus 5, because that's the a squared, right? This is a squared minus b squared. So we don't even have to square them because that would be doing the same thing. And so I square root them. You don't have to do the plus or minus. Well, I mean, you can, but you just know it'll go up or down. So we got the square root of 22, which as a decimal, because I like to do with decimals so we know we can put on a graph, it's like 4.7. So if you were to look at this, okay, 4.7. 4.7 would be, and let me use orange, 4.7 would be like somewhere in here and somewhere in here. So it's always right inside of my major axis. If it's not in there, there's something wrong. But what that means is that if I were to draw this ellipse, what would happen is I would, at those 2 points, if I had a pencil with a string on it with this distance, and I went around, I would have an ellipse shape that's there. So that's kind of what we're looking at. So the foci would be at, there's 2 of them, right? 0, 4.7 and 0, negative 4.7. So those are my 2 foci points moving forward. Now, let's go to another one. Hopefully this will help us out a little bit. Oh yeah, and also is eccentricity. I can look at that a little bit more in class, but if you see that on your homework, you can just identify with this. It's always my C over my A. So my C in this case was 4.7. Okay, my A is 5.2. So if I take 4.7 and divide by 5.2, I should get a decimal, so 0.904. And it's used for like planets, orbit, that sort of thing. I don't think I'm going to really ask that on the test, but it is on the homework, so in case you need that there. I'll leave it at that. You see the formula here, so if you just divide C over A, that's how you get your eccentricity there. Okay. Now, the last kind of few that I want to do is I want to do 2 of these. So I want to do number 13 and 15. So on 13, let's look at that one. On this one, we want to try to get it into a form that we recognize. So in order to get it kind of in that form, we're going to make sure that this is equal to 1. So we're going to divide by 36. Notice there's not an x or a y by itself. There's only the y squared and x squared. So we don't really need to make a perfect square here. All we need to do is say x squared over 9 plus y squared over 4 equals 1. Now, because this is in our regular form now, we're able to identify that and be able to, well, we can solve for it. So we can go 0, 0. We know that a squared is 9. Okay, because if you look at your form, a squared is 9, where b squared is 4. You might say, well, why is a 9? Well, remember, a is always the greater one. It's always the greater one. So since we know that a squared equals 9, we can square root it to where a is equal to 3, meaning we're going to go, because it's underneath x, we're going to go left 3 and right 3. And so my vertices are 3, 0 and negative 3, 0 because this is my major axis. You'll see in a second. B is 2. Okay, both up and down because it's underneath y, right? Okay, that's why it goes up and down. And so as I draw this, here's my ellipse. That's a pretty doggone good ellipse there. I'm working here. Work, 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 work. All right, so as we do c squared equals a squared minus b squared, we can do the 9 minus 4, okay, and square root it to get c by itself. So c equals the square root of 5. Now let's go to the square root of 5 real quick. And well, actually, we can leave it as is because I think I did it on the homework sheet. So my vertices are here. What else do I need? I've got my center 0, 0. The only thing I need is my foci. Well, I know my foci's got to fall somewhere in here and here. So to do this, what we can kind of do is start with your center 0, 0, and I know I go right square root of 5 and left square root of 5. Okay, so I take 0, 0, and the only thing changing is the x. So my foci would be square root of 5 comma 0, and then I subtract it, negative square root of 5 comma 0, and that's what my foci is from my center. Okay, so I think square root of 5 would be like 2 point something. So my foci would be there, about right there. Okay. All right, hoping this is helpful for you. Let's keep going. I think we've got one that, man, this does get tricky here. This one's a little tougher. Let's go to number 17, okay? Let's go to number 17. Let's see if we can, actually, let's go to, I want to make sure I got it. 15. Let's do 15. All right, so we have 9x squared. Let's put all the x's together, okay? So since we have something that just has x by itself, we've got to put x's together. I'll leave that there, and then I'm going to put y's together. So I've got y squared and 4y squared, I'm sorry, and minus 24y, okay? And I want to subtract 36 to the other side. Okay, take it to the other side. So before I do my perfect square, let's take out something in common. Pull out that 9. All right, 4x. And let's pull out that 4. Okay, so right now we're just kind of breaking this down. All right, so now I've got to add something in here that gets me a perfect square for both of these. So let's do this. Let's half 4 and square it. Half 4, I get 2. Square it, I get 4. Okay. Half -6, I get -3. Square -3, I get positive 9. Now, here's the kicker. If I add 4 here, this is not just, if I do it to one side, I got to do it to the other. But it's not just 4. Because the 9's on the outside, it's really like adding 36 to the left side. So I have to do it to the right side. Same thing here. It's not just 9. It's really 36 again. So I've got to add 36 on this side. Okay. So that cancels, leaving me with 36 equals, okay, leave the 4 here, and then 9 here. Because now I know that there's a perfect square. What two numbers multiplied equal 4, added to be equals 4? Well, it would be x plus 2, which is x plus 2 squared. And this one should be y minus 3 squared. Look at our form now. We're starting to get it there. Now it needs to be equal to 1, so I divide by 36, divide by 36, to where x plus 2 squared is over 4 plus 4, oh, I'm sorry, this is gone, because 4 goes into 36 9 times. And we have y minus 3 squared. Now, if 9, let's say both of these were 9, this would have to be a circle because the major and minor axis would be the same, resulting in a common radius. Okay, just making sure we know that. So now the center should go left 2 and up 3. Left 2 up 3. And my a squared is equal to 9. It's going up and down because it's underneath y. So really a goes up and down 3. So I'll start here, go 1, 2, 3, boom. 1, 2, 3, boom. Square root 4, I get 2, so I'm going to go right 2, boom, and left 2, boom. So what I have now is I've got my ellipse that looks something like so, okay? So that's my ellipse. Again, my major axis being up and down because it's underneath y, and my minor axis is on the x or on the horizontal side. So my foci is going to transform up and down this line right here. Oh, I'm sorry, this line right here, up and down. So how do I find what the distance is from the center? Well, I can find c by doing the 9 minus 4 that we did, okay, and square rooting both sides. So c is equal to the square root of 5, okay, square root of 5. So now since c is square root of 5, we can move this from our center, come to our center. Remember our center was -2, 3. And since we're moving it just on the y, we can keep the first one the same. So the foci, we can keep that -2 the same and do plus 3 plus square root of 5. And then also keep that the same, 3 minus square root of 5. And so as a decimal, you could kind of plug that in. It should be about 5 point something here. So it should be about right there. And this one should be about point something, which should be about right there. Okay. You kind of get a decimal on that, but really, if you could leave it as is there, you don't really have to graph it as much as just find it is the big thing. So that's kind of where we're at there. You can kind of leave it as is and go from there. As far as the graphing utility goes, don't worry about that part. Really, if I can talk, worry about just sketching it and finding everything else with that, okay? And then also eccentricity, you could just do the c, which would be square root of 5, over the a, or actually, square root of 5 over the a, which would be 3. So square root of 5 over 3, get that decimal, and that's how you find the eccentricity of the ellipse. Okay? All right, let's do 2 more of these. And then afterwards, again, if you need some more help on Thursday, we can go through that online for about 30, 40 minutes or so. Okay? Now, on this example, we know that the center is at the origin, because it says it. So we know that we can just leave it in our form, x squared plus y squared equals 1, where a or b is underneath here, right? We don't know what it is. In 23, since it's larger on the top than the horizontal, we know a squared, or the larger value, is underneath y, whereas b squared is going to be underneath x. So as I look up, I go 1, 2, 3, 4 up and 4 down. So because of that, we know that a is equal to 4. because B goes left to right 2, we know B equals 2. So simply, all we have to do is plug 4 in for A, we square it, we get 16. And we plug 2 in for B to get 4. So what we have now is x squared over 4 plus y squared over 16 equals 1 because of that lack of transformation that's there. Okay? Hopefully that's helpful for you. Let's look at one more here. Let's get number 35, okay? Now on this one, it tells us to find the standard form. Now, in order to kind of figure this one out, in fact, let me do this. Save that. Get that. No, not quite. Let me see if I can get one of these. Get this here. Copy this over. On this example, the problem with this one more than the other one was the fact that the origin is no longer the center per se. We're not sure what it is, but that's what we're gonna figure out. So on this one, we want to try to find what it is in standard form. Now, the major axis, it has a length of 8. Okay, so 8 is the major. Okay, remember that that's not the whole thing, right? Remember that's just like as far as like the whole major axis is 8, but that doesn't mean that that's A. Remember, in order to find A, we have to half it, right? So A is going to be 4. All right, so we know A is 4. We also know that if the foci is at 0, 0 and 4, 0, we know that if these are the foci, that the A falls underneath the x minus h squared. So we can do this one, x minus h squared, because we don't know if the center's in the origin, plus y minus k squared equals 1. We know the A is underneath the x because it's left to right, and the B is underneath the y. Okay, so we've got that. Now, in order to find the h comma k, we know that between the foci, the center would have to be at 2, 0 because it always falls between wherever my foci are. So since it's 2, 0 is the center, 2 is h comma k, right? So this should be h. So we have x minus 2 squared plus y minus 0 squared, or just y squared, equals 1. Now I plug 4 in for A to get 16. And in order to find what B squared is, we notice that the foci distance within this is, I want to make sure I've got this part. Okay, got this. So hold up. This is, I think, what one I'm making. Oh, I'm sorry. I'm right. I messed up on this because when I looked at it, I kind of flubbed up. I'm doing number 34, not 35. So I was kind of just looking at that one and I was messing myself up. I apologize. So on 34, we're still on 34, by the way. On this example, we know that the whole thing is 4, so the distance of the foci would be 2. So really we have c squared equals a squared minus b squared, where c is 2, so 2 squared is 4, a is 4, a squared is 16, minus b squared. So when I subtract 16, I get negative 12 equals negative b squared. Both are positive because we can change that both sides. Square root, where b is equal to the two square roots of 3. So really all you need to do, we need to find what b squared is. So we know b squared was equal to 12. We come back up here. And what we have there is our standard form equation. And all I did was just work backwards from that. So what is the distance from, again, we found the center because we found the midpoint between 0, 0 and 4, 0. We know A was the greater, the one that has A underneath because, again, the foci always falls inside the major axis. We know C was 2 because it's, again, the only one way between the center to the foci. And we also notice that the major axis is 8. And that means that we'll go 4 to the right, and I'll even draw this here. Okay? From my center, we'll go 4 to the right to be at 6, and 4 to the left to be at about negative 2. So again, that's kind of where my vertices are, and that will help me to determine where I'm at. So again, center's at 2, 0, which is exactly right. Foci is inside my major axis, And because it's on the x, therefore the larger value, a squared, would be 16 on the bottom of that x squared there. Okay? All righty. Hoping that's making a little more sense to us here. I'm trying to see if there's any other ones that I'm like, man, we really need to look over. Trying to see. Okay. Want to make sure we're good there. I think that one's good. All right, if you need any more help, what we can do is look on a little bit more on Thursday with it. The ones that I'm really concerned about, if I'm honest, would be the ones that we did earlier, this one. I could get you started on another one if you want me to. If you look at number 17, and I'll just kind of start you there. I'm going to do this one a little bit quicker. Get the x's by itself. Okay, so I've got this. Get the y's by itself, so 2y squared minus 10y. And then that positive 2, subtract it to the other side. Okay? Pull out that 6. That's what we did earlier. Okay? And pull out that 2. Make sure this is positive, because you'll see why a little bit on the next podcast. Okay? And half it and square it, right? Now, oh man, this one does get a little nasty, because as I half and square it, this one's going to be a fraction. So half 3, 3 and then square it, it'd be like 9/4. And on this one, half 5 and square it would be like 25/4, something like that. And so I would have to also then add that to the other side, not just 25/4, but 6 times 9/4 and 2 times 25/4. So again, that one's one that's a little bit tricky. On that one, one like number maybe like 16 or something is one that may be a little easier for you. But again, that's just kind of what we're doing. Putting x's together, put y's together, take what's out in common, half and square it to get a perfect square. Make sure if I add one thing to one side, I have to add it to the other. And not just that value, but if I have something on the outside, make sure that's applied as well. All right? All righty. Man, I hope that was helpful for you. I had a lot of just little things on that. So if you have any questions on it, please make sure you message me or contact me, and we'll go through that together a little bit more on Thursday night if you need some help on it. Thank you all so much, and care about you. Have a good one. Bye.